Okay, now we go to our third and final cycle, which is a heat pump. Okay, heat pump, which we're going to draw the same way that we have before. We're going to have our hot reservoir, or our high temperature. We're going to have our cold reservoir, which is our low temperature. And we're going to have our cycle here, okay, which is what we're looking at. This is our system. Okay, that's what we're going to have, just like we had before. Nothing new here. But here's what's going to be with the heat pump. Heat pump, we're going to have our Q in, our heat transfer in, coming from the cold reservoir, and our Q out going into our hot reservoir, and we're going to be providing some power or some work coming in here. And you may pause for a minute and say, well, Dr. Wanklin, I just drew a diagram exactly like that for a refrigeration cycle just right above. And you are exactly correct. We did. The difference between this one and the previous one is now we're worried about up here now. We're concerned with the hot side. Okay, refrigeration cycle is concerned with the cold side, and the heat pump cycle is caring about the hot side. Okay, just so basically, and this is oversimplifying things dramatically, but if we were to take a refrigerator, and it was a very cold day outside, and we would turn the refrigerator around and put it into our house or in our door. We'd open up our door and put the cold side out and the hot back side of it in, and we would run it and we'd blow that hot air into our house to try to heat our house. That is a crude heat pump in some ways. Now, what's really happening for a heat pump, we're going to jimmy with it and make sure that it's modified so that it's really really concentrating on that flow of heat out and minimizing that Q in. Like a refrigerator, we want it to hopefully it maximizes the Q in and it reduces the Q out. But that's what these things are. And now you can sometimes buy refrigeration systems. Sometimes, like when we bought the air conditioning for this house, one of the options was to buy a heat pump, and the heat pump is basically a refrigeration. It is a refrigerator and air conditioner and heating system all in one. They just run it a little bit differently in different seasons to try to get you the cooling or the heating that you need. And heat pumps are usually used in when there's mild winters. That's where you're going to see a lot of heat pumps, where there's mild winters. And there's lots more information for you to read about that, but I'm going to waste your time if I talk. I'm not waste your time, but I'm going to take a bunch of time talking about what a heat pump is and how it actually works. But let's go to the analysis here. And we're going to say here, again, that's the change in energy for the cycle is going to be equal to the net heat transfer minus the net work. Okay? And we know, again, that for the cycle, it's going to go to 0. And we're going to have the following. 0 is equal to, well, for this, the net work is going to be equal to Q in minus Q out. And we're going to have a minus net work. Just exactly the same as what we had for a refrigeration cycle. And so we're going to get here that the work of the cycle is equal to Q out minus Q in. Just exactly the same. And I'm going to put magnitudes here so we know that we've taken care of the signs and we don't have to worry about that. Okay? Exact same as a refrigeration. But what we have to understand, and look, we got a cat that's joining us here. Hello, cat. That's Finn. That's Finn the cat. He looks like he's looking over my shoulder or sitting on my shoulder. Hi. He's very interested in thermo. He's not. He's not interested in thermo at all. He's interested in eating. That's what he's interested in. Okay, now he's going away. All right, so we're going to be calculating the coefficient of performance. but it's not going to be the same coefficient of performance as we had with our refrigeration cycles. So we're going to call it gamma. Okay, it's still going to be what do we want over what do we have to give. But we're going to have to look at it a little differently because we don't want the same things as what we wanted in a refrigeration cycle. What do we want in a heat pump? We want Q out. Q out is what we want. What do we have to give for that? Well, we still have to plug in a heat. We still have to provide power or work into it. So we're going to have our net work or work over cycle. And I'm going to put magnitudes here. And we can rewrite this as Q out all over Q out minus Q in. Okay. And again, you cannot write this as 1 minus Q out over Q in. That algebra does not work out. Make sure this is the same as what we did before. And we also remember we can do this as rates. We can put this as rates and nothing changes inside of our problem. Okay. Heat pumps. Now, heat pumps and refrigeration cycles are the same, and if you had an unknown cycle, so let me write this up here as a note. If you have an unknown cycle, we said that if the network is positive, it's got to be a power cycle. If you have an unknown cycle and the network is negative, the network is negative, it could be either a refrigeration or it can be a heat pump. We don't know for sure. We can find out more about that later as we get to be better understanding of thermo, but right now our major things are if it's a positive network, it's got to be a power cycle. If it's negative, it could be the refrigeration or heat pump. We're just not really sure right now. Okay, so that is a heat pump. That's a heat pump cycle.